Good morning, students. In yesterday's class, I explained you similarity related various theorems. See, students, for similarity, what we know is that if there are two figures with the same shape, they are said to be similar. At the same time, there are three criteria for similarity. To prove any two triangles similar, we can use AA similarity if two of the pair of angles, corresponding angles of the triangles are equal. Next is SAS, the ratio of the sides, if that is equal of the two triangles, corresponding sides ratio, and one of the angles, pair of angles in the two triangle is equal. And the third one is SSS, when the ratio, where the three sides of the triangle, of both the triangles are in proportion. Okay, corresponding three sides of the two triangles are in proportion with each other, then we say that the two triangles are similar by SSS similarity. Now what we discussed yesterday was not only this, but also we proceeded further. We talked about the basic proportionality theorem, BPT, which is also called as or the Thales theorem. We talked about its mathematical proof and the converse also of the basic proportionality theorem. We discussed the derivation, the proof of that as well. Now today we are just going to quickly recapitulate what this statement actually talks about. Okay, if this is a triangle ABC given, ABC is a triangle such that DE line is parallel to PC. This is given that DE line is parallel to PC. Then these two sides A, B and AC, they are divided in the same ratio. Now what do I mean by that? See, if this is given, if it is given that in triangle ABC DE is parallel to BC, then the two parts AD and DB ratio will be equal to the parts AE upon EC. This is BPT theorem, basic proportionality theorem, Thales theorem, which we call it as. Okay, if the two lines are parallel, DE is a line parallel to PC, then this is what we have as a result by BPT, basic proportionality theorem. When we talk about the converse of this theorem, it is also true, my dear students. Now what that say is, if the two sides ratio we take and they are in proportion such that AD upon DB is equal to AE upon EC, that is given, then we must have DE line must be parallel to BC. So that is what it is, just the given becomes a to prove and to prove will change to given. So that is the converse of basic proportionality theorem. As per what is given in the question, we are going to use the result of BPT theorem, okay, with the help of which we can prove the ratio of these two sides parts in proportion, and at the same time we can prove the lines DE and BC parallel as well using the converse of BPT theorem. Okay, so also we discuss after this an important property which was related to the internal bisector of an angle, that theorem. Okay, so what it states is, the internal bisector of a triangle divides the opposite sides in two segments that are proportional to the other two sides of the triangle. At the same time, if I am talking about the internal bisector of an angle triangle theorem, the converse of it is also true. Okay, I explained you in yesterday's class question number 1. Okay, we discussed question number 1. I explained you all the three ABC part. Now today we are going to continue with question number 2. So everyone please focus and look at the screen. Okay, I gave you up till question number 3 as homework. So I'm discussing today question number 2, which I gave you as homework. See students, in the given figure DE is parallel to BC. Now it is given that DE line is parallel to BC. Now by BPT theorem, what do I know? If DE is parallel to BC, then the ratio AD upon DB must be equal to AE upon EC. And to write this, what is the reasoning that I am going to give? That reasoning which I have to give here is by BPT theorem. Now what all is given? AD is given x, DB is given, this part is x plus 2, this is x minus 2, A to E, this is x plus 2, and E to C it is x minus 1. So all the values are given, we will just substitute, and by cross multiplication we can find the value of x, right? This was the homework question, so I am discussing it. If there is any doubt, you can now understand this. Second part of the question was, if db is x minus 3, this is x minus 3, a to b, this total length is 2x. Okay, a to b, the total length is 2x. Now we are taking a part db and the total length is given ab. At the same time, if the other side I talk about, again the part ec is given and ac, the total length is given. We are supposed to find the value of x. Now for that part, what we'll do, again in triangle abcd is parallel to bc. So not only that part which we are talking about, also this is true that ab upon db, this part and this total side ratio, it will be equal. The part of the line, that is dB upon AB, the total line, will be equal to EC upon AC. Okay, so this is the result. Now we are going to substitute the values. On substituting, this is what we get. To find the value of x, what will you do? Same as the first question you did today. You'll do the cross multiplication and hence you will find the value of x. Here again I am repeating, students, you cannot just proceed with this only. You need to give a reasoning over here. What's the reasoning? By BPT theorem. So it is actually the result of basic proportionality theorem. The way I have told you for this part, first question, you need to write it here as well, by BPT theorem. Okay, all of you must be able to understand by now this thing, that it should be by BPT theorem. Okay. So that's what the result is. You need to give the reasoning. That's why I'm writing it also, so that there is no confusion left whether it is to be written or not. It's important. You need to write that. Now let's move to the next. See students, here we have solved it, and on solving you get the value of x as I've discussed. Fine. Now let us move to the next question. In the next question, what is given? E and F are the points on side PQ and PR. See, there is a triangle PQR. E and F are the points on side PQ and PR. Fine. Okay. And for each of the cases, state whether EF is parallel to QR. Again, students, we need to prove here, we need to state whether EF is parallel to QR or not. Now to prove it parallel, let us see what we are going to do. We are going to use these sides. Okay, for the first part, there are two cases given. For the first case, we are going to put all the values. What all are the parts? Yes, it is P, F, F, Q. P, F, F, Q. P, E, E, R. That is one of the results of BPT theorem. Also, we have the another result as, okay, the total length, that is PQ upon this part PE. Okay, the part and the total line, that ratio will be equal to PR upon P. So that is what we are going to take. We are going to take the ratio, and if the ratios are coming equal, we know this is what? This is the converse of PPT. So this should be very clear. If the ratios are equal, then we can say by converse of PPT, the two lines EF is parallel to QR. So this is just the opposite of that previous one. Now let's move further. This was all your homework part. Okay, for both the parts you can do it the same way as I've explained you all just now. You can do it for both the parts. You can take the sides and then you can prove it. If the ratios are equal, we'll say that the lines are parallel. If the ratios are not equal, the lines are not parallel. Okay, and what we are using here as the concept is the converse of PPT theorem. Now see question number 4, what it says. From here we are going to continue. A and B are respectively the points on sides PQ and PR of a triangle. A and B are respectively the points on sides PQ and PR of a triangle PQR. So PQR is a triangle, and in that this is given such that PQ is given, P to A is given. So the total length PQ and a part PA is given. B to R a part is there, and this PB is given. Is AB parallel to QR? Give reasons for your answer. So I think by now you must be able to understand. To prove the result, what we are going to do is we are going to check the ratio of the sides. Okay. In triangle PQR, A and B are the points. Like this we are given. Of the sides PQ and PR, A and B are the points. And these are the values given. PQ is given, the total length. P to A is given. Okay, BR is given. Here you need to do a correction, my dear students. Okay, this side it is A and the other side it's B. So this side you will have A and here you will have B. Okay, now it's fine. And here you will have A. Fine. I hope now the things are clear. Okay, A and B points. Now what we are having? PQ, the total length, PA, this part, PBR, this is the part, and PB, this length is given. Okay, so what do I know? Yes, I'll take the ratio to prove the two lines parallel. I have to prove that whether, I have to check whether AB is parallel to this line, AB is parallel to QR or not. Okay, so we'll take the ratio PQ, the total length, upon the part PA. Similarly, on the other side, what will you take? PR, the total length, upon P as the part. So do we know the value of PB? Yes, it is 4. Do we know the value of PR? This is P to B is 4. We will use this result. P to B is 4. So this value is 4. And B to R, it is B to R, it is 6. So this is 4, this is 6, it will be total 10. Now I know all the values. I'll check the ratios. Here the ratio is coming 2.5 ratio 1 and here also it is 2.5 upon 1. So I can very clearly see that yes, the two ratios are equal. So we can say by converse of BPT, AB is parallel to QR. So this is very, very important. Again I'm repeating, you need to know it's the converse of BPT theorem. It is converse of BPT theorem. Okay, so using that result you are getting it as AB is parallel to QR. Now let's move to question number 5, what it says. See students, question number 5. In the given figure, so this is the figure given, DE is parallel to BC. We can see ABC is a triangle, D is point on AB and E is point on AC. It's given in the question, DE is parallel to BC. So these two lines are given parallel to each other. DE is parallel. Let me draw it for you so that there is no confusion. DE is parallel to BC. The two lines are given parallel. Okay. And BD is equal to CE. B to D, this part is equal to C to E. These two are equal. It is already marked in the figure, so no need to do it again. So these two are given equal. Prove that triangle ABC is isosceles. Better see, these two parts are given equal. To prove triangle ABC isosceles, isosceles is which type of triangle? A triangle in which any of the two sides are equal. So we need to prove AB and AC, the total length of these two equal. Let us see how we can proceed. First of all, what is given? DE is parallel to BC as I have shown you in the diagram also. And BD, this part BD is equal to part EC. What do we have to prove? We have to prove triangle ABC is isosceles. That means I need to prove here only you can take it as AB equals to AC. The total length of the line equal. Now in triangle ABC, if DE is parallel to BC by BPT theorem, again here by BPT theorem what we can say? We can say this part AD upon DB equals to AE upon EC. Parts and the total side. So we are taking this AD upon DB, the two parts, and here also we are taking the two parts. See, depends on the question what you need. You can also take it as if it was needed as we were doing in previous question, AB upon DB, AC upon EC. So like that, depending upon the question you can take it. Fine. So let's proceed. We have taken this. Now DB and EC. What can we say about BD and CE? The two are equal. So beta, will the two get cancelled? Yes, these two will get cancelled. Okay, we will be having DB cancelled with EC. So what am I left with? If these two are equal, these two will be cancelled. I am getting AD equals to AE. AD and AE are equal. So beta, add the equal parts. So easy to understand. Okay, we were having DB equals to EC. Add the equal parts. Okay, so DB plus AD, these two will be added. EC and AE, equation number 1 and 2 on adding, I get the required result AB is equal to AC, which proves the required result triangle ABC is isosceles. Again, I am repeating what we have done so that there is no confusion in this particular question, my dear students. See, we are given that DE is parallel to BC, so we are using BPT theorem. What we are using is basic proportionality theorem. BPT theorem result we are using, and this is what we get. AD upon DB equals to AE upon EC. Okay, now using BPT, this is what the result we get. Okay, this result we are getting using the basic proportionality theorem. Okay, so this is the reasoning for it. Reasoning is by basic proportionality theorem we are getting it. Okay, and then we are given DE equals to EC. So if the two are equal, they will get cancelled from both the sides. Once they are cancelled, AD is equal to AE. Adding these two equations, we'll get the required result. AD plus DB equals to AE. We'll add left to the left part and right hand side with the right hand side. This is what I get, and the required result is there, that I get to prove that AB is equal to AC, which proves the required result, that by BPT we have done this, and AB equals to AC, so ABC is an isosceles triangle. So this is all about fifth question. Now let us move to the next question, my dear students. In this particular question we have one more part, so exactly the same it is. You can do it as homework. Let me move now to the sixth question. What it says: in the figure given below, CD is parallel to CD, you all can see, is parallel to LA. So let me just mark the same. CD line, this line is parallel to LA. So that means these two lines are given parallel. Okay. Then what else is given in the question? CD is parallel to LA and DE is parallel to AC. So this is their DE line parallel to AC. So this is the second case, DE parallel to AC. Find the length of CL. Find the length of CL. This part we have to find out. Okay, when BE, this part is 4. This is given as 4. And this E to C is given as 2. This is 2 and that is 4. These are given to us. So let us work out for the question what is given, and let us use the BPT theorem for getting this. Okay, so here we are. See, we are given CD is parallel to LA and DE is parallel to AC. This pair is given already, and the length of BE and EC, as I was showing you in the figure, that is also given as 2 cm. Now let us take the triangle BCA first. Okay, because there are two parallel sides. We have pair of parallel sides. So we'll firstly take triangle BCA in which DE is parallel to AC. So this is corollary of basic proportionality theorem. What is it? BE upon BC equals to BD upon BA. Okay, now BC can be written as, beta, it is the sum of the two. Total BC is the sum of the two, BE plus EC. So that is what I can write, is equal to BD upon AB. What is the value? BE is 4, beta, and BE plus EC, that is 4 plus 2, 6. Okay, so this part is clear. This is the first equation that I get. Now in triangle BLA, because one more pair is given, CD is parallel to LA, let us use that also. Again, the basic proportionality theorem is what we have. So we are going to use that, BC upon BC plus CL. BL is what, beta? B2L. It is the sum of BC and CL. Okay, is equal to BD upon AB. Now B to C, that means the total 4 plus 2. Again it's 6. BC we will put 6, and CL, which is not given, will write it B as it is CL. Okay, now from these two equations, what can you say? We can very clearly see that these two parts are equal. We can very clearly see that the right hand sides are equal in both the equations. In equation 1 as well as in equation 2, I can very clearly see that the right hand sides are equal. If the right hand side of two equations are equal, what can you say, my dear students? Yes, you can say if the right hand sides are equal from equation 1 and 2, the left hand side will also be equal. So let us equate 4 upon 4 plus 2, that is 4 upon 6 equals to 6 upon 6 plus CL. Only term missing here is CL. I know very well, you can find out that. How will you find out? By using cross multiplication. 6 6 are 36, 36 upon 4, okay, and then that is equal to 4 6 are 24 and plus CL. So work out all the calculations. What do we get? CL as 3 centimeter. Fine, students. Second part is similar one. So I'm not explaining you. We have just now done proving the triangle isosceles. So you are going to do it as homework. Now this is question number 7. Last question for the day. So work out all the homework parts other than this, and then we'll discuss and complete the remaining exercise. The last question for today, please see students what the question says. Question is, in the given figure ABC, in the given figure ABC are points on OP, OP, OQ and OR. We are having a triangle PQR and O is a point in between, and that O is joined with OP. On that there is a point A, OQ there is a point P, and OR there is a point C. We can very clearly see it in the figure 2. What is it? Such that AB is parallel to PQ. AB, this is parallel to PQ. This AB line is parallel to PQ. So this is already given in the question that these two are parallel. AC is parallel to PR. Now these two are also parallel. So you can see one more pair of parallel lines we have. Which two? AC AC is parallel to PR, this particular side. Now which is the third pair left? Without seeing the question also you can easily make out that the third pair left is BC and QR. We have to prove these two lines are parallel. So can you see that there is a triangle POQ? Yes. Can you see the another triangle POR? Yes. We have pair of parallel sides, my dear students. And you know this part OA upon AP is common in the two. So using that we can work it out and somehow get the result. Very easy question. Let us start with it. Okay. In the given figure, ABC are points on these lines respectively. This all is given part. So we are writing it. What we have to prove? BC is parallel to QR. Now first of all, I'll take triangle POQ. See students, triangle POQ. What do I know in that? AB is parallel to PQ. So by BPT theorem, this is how we are getting. Again, I'm repeating. You are getting this result by BPT. Question 1 and 2 both are because of what we are using is BPT theorem. For both the result in equation 1 as well as in equation 2, we are using our BPT theorem. Fine. So it is applicable here also, and it is applicable in the next one also. Fine. So by BPT we are getting two results. One is this and the other is this. These two equations are by BPT we are getting. Okay. So now this is the first one. Let us take the another triangle POR. In that AC is parallel to PR. If these two lines are parallel, then we have the parts OC upon CR equals to the other part OA upon AP. Now what can you see very clearly? Again we are going to check. We have pairs equal. See the part. Yes, students. What can you see? OA upon AP is there in the first equation also, and OA upon AP is the same in the second equation also. Okay, if the left hand side of these two equations are same, then the right hand side should also be equal. So from equation 1 and 2 I get OB upon PQ. See, OB upon BQ, these two part, OC upon equals to OC upon CR. So what am I going to use to prove the two lines are parallel? Yes, students, it is the converse of BPT. What am I going to use is converse. It is the converse of BPT. Okay, using this converse of BPT, I am able to prove it. Fine, students. So that is what it is. So this was the result. Should be very clear to you all. By converse of BPT, we are able to prove the required result that BC is parallel to Q1. So that was all for today's class. I hope all of you have understood. For any doubts, you must approach me. God bless you all. Complete your work up to question number 9 in the next class. I'll take the doubts if you have any. God bless you.